Hello children, welcome to Yamuna's physics classes. Today we have to discuss the topic 9.3 of ray optics, that is refraction, and here we are going to discuss what is refraction and the laws governing refraction. Now we are familiar with rectilinear propagation of light, and moreover ray optics itself means the light is traveling in a straight line. Okay? But is that we able to bend it? We know it is yes, because in younger class or smaller grades itself we have done that. Just we have a glass of water like this. If you have a glass of water like this, you can see that it is bending. And if it is, when you watch it, you can see that at the interface, the bending happens exactly at the interface between water and air. In the air, the rod is straight. Again, inside the water, it is straight. But at the surface of separation, we can see that it is bending. So, be clear with the term interface. Interface means the separation between air and water. Okay? Clear. Now, let us come to the definition of refraction. What is refraction? Refraction of light is a change in the direction of the light. That is what you call bending. It's just getting bent at that surface when it is traveling obliquely. Oblique means what? Angle of incidence should not be 0. Any angle other than I equal to 0 is okay. From one medium to another. So let us come to the picture and the details. So here comes the picture, and here you have two medium. Number one, first medium, it is air. Light is coming from air and it is passing, it's just entering the glass slab. You have a glass slab here, so light is coming and falling on the glass. So at the surface of separation or the interface, that's a word interface, between the air and the glass. Let it be at the point this. This is known as the point of incidence. So the yellow shaded line, incident ray, falls at the point of incidence of above the glass slab. At that point it gets bent. Actually it should go in this manner. This is the direction. But just because it enters another medium too, that is glass, it gets deviated from the path. This phenomenon is known as refraction, and it's very important. I should not be 0. What do you mean by I equal to 0? Incident ray should come parallel to the normal, because angle between the normal and the incident ray is known as angle of incidence. So if the incident light is coming like this and it is falling like this, it's like a mirror itself, plane mirror. We have discussed in the last video. If it is a plane mirror, light comes just perpendicular, again return back in the same manner. So I should not be 0. For any angle other than 0, refraction takes place. So that is refraction. Now, why do you have refraction? That's a question. Very simple answer. The difference in the velocity of the light. So it is caused, bending due to the interface is caused because change in speed of light. Look, you know, it is very familiar. For air or vacuum, velocity of the light is 3 into 10 to the power 8 meter per second. Sunlight is coming from through a vacuum, then entering the atmosphere. Even then the velocity is the same. But once it enters the glass, in glass the velocity is just 2 into 10 to the power 8 meter per second. And we say that this velocity, here the medium velocity is lesser, meaning it is more denser, rarer, denser. Rarer means the particles are far apart. The number of particles are low. But when you come to denser, it is thickly packed. So it's like traveling on a pocket road and then going to highway. Rarer medium means your pocket road where you don't have that kind of population. But once you go to national highway, the number of people, the number of vehicles are much more, you have to slow down. So the velocity comes down. So when you go from rarer to denser, the velocity is coming down. As a result, the bending also comes closer to the normal. So when a ray of light goes from rarer medium to the denser medium, it goes. That's how. We'll answer how. It can either deviate in this manner or in this manner. So the deviation depends on light is coming from which medium to which medium. So if we are coming from pocket road to national highway, you will go down with the speed. The reverse. When you are coming from national highway to the pocket road, you can increase speed. So that's the reason. So when it is coming from rarer to denser, it bends towards the normal. When the reverse, it bends away from the normal. So three things we have answered: what, why and how. Now comes the laws of refraction. The laws of refraction. The first law is familiar to you, same as law of reflection. Only changes, instead of using reflected, you use the word refracted. So incident ray, refracted ray and the normal. So the same colors, incident ray, refracted ray, normal. At the point of incidence, that's very key word. At the point of incidence, all should lie in the same plane. All these things have drawn in the plane of the board. So the plane should be the same. Here the plane is the surface of separation. All the three should lie in the same plane. Clear? Now, second law. This is familiar one. Second law is the most important law of refraction, known as Snell's law. It says the ratio of sine of angle of incidence I. Angle of incidence, you know, the angle between incident ray and the normal. Take the sine of I to the sine of angle of refraction, the refracted ray and the normal. This angle is R. So sine I by sine R is always a constant known as refractive index. So we will say first medium air, second medium glass. So we will say sine of angle of incidence in air, that takes place in air. Sine of angle of refraction, that takes place in glass, is equal to refractive index of glass with respect to air. So N21 meaning refractive index of second medium, that is glass, with respect to first medium, that is air. So we will have another video to detail what is refractive index. So now we are not going to detail that. But this is an important thing to note regarding refractive index. Refractive index depends on velocity of light and wavelength of light. It is independent of angle of incidence and also frequency. So I told you, if the velocity, here it is 3 into 10 to the power 8, here it is 2 into 10 to the power 8. So when velocity changes, refractive index changes. Accordingly, just by the value of refractive index itself, we can say which is rarer, which is denser. For example, if you take diamond, the refractive index for glass, it is 1.5. When you go to diamond, it is nearly 2.4, means highly denser. So it will be again bending towards the normal. So it's very clear, velocity and wavelength depends on refractive index. Higher the refractive index, the bending will be much more. Refractive index actually says how the light is slowing down. You know, it is bending. How much it bends, the extent of bending actually can be mentioned by refractive index. And one more thing, it is independent of angle of incidence. Whatever be the angle of incidence going, refractive index won't change. You can go to 0, any maximum value, refractive index will be the same. And also it is independent of frequency. Frequency of light in medium 1 and medium 2 remains the same itself. Okay? Hope it is clear. Thank you for listening. So you can have any comments, any doubts in the comment box. Okay.